Good morning, sir. Good morning, everyone. Myself, Alok Kumar Das. I am from the Department of Physics, Dibrugarh University. The title of my presentation is Effect of Deposition Time on the Structural and Optical Properties of Cadmium Sulfoselenide Polyvinyl Alcohol Thin Films Prepared by Chemical Bath Deposition Technique. So first of all, I will be talking about the introduction. The compound cadmium sulfoselenide is an important 2,6 semiconductor compound and is an important member of the chalcogenide group. The compound cadmium sulfoselenide finds wide applications in solar cells, optoelectronic devices, field effect transistors, light emitting diodes, etc. The compound PVA, polyvinyl alcohol, serves as a polymer matrix and is a capping agent. Cadmium sulfoselenide PVA thin films in this present work were prepared by chemical bath deposition technique. 3 samples were deposited on glass substrate in a basic bath solution at bath deposition temperature of 75 degrees C for 1 hour, 2 hour and 3 hour respectively. The samples were accordingly coded as S1, S2 and S3. The pH of the bath solution was maintained at around 10 with the help of aqueous ammonia. The effect of deposition time on the structural and optical properties of the CdSSe thin layers were investigated using X-ray diffraction, UV spectroscopy, FTIR and PL spectroscopy. The motivation behind my work is that cadmium sulfoselenide is a promising compound widely used in semiconductor devices. This compound is also used in making solar cells, optical filters, waveguides, etc. The band gap of this compound can easily be tuned depending on the stoichiometry of the compound. This compound, cadmium sulfoselenide, has got high chemical stability. This compound also has got a wide band gap ranging from 1.7 electron volt to 2.5 electron volt and also has got high absorption coefficient. Methodology. The substrate we have used here were chemically clean Rivera glass slides. The deposition type was chemical bath deposition. The bath temperature was fixed at 75 degrees Celsius. The time of deposition were 1 hour, 2 hour and 3 hour respectively. Spectrophotometer we have used here was Simarjo UV 2600. The chemicals used were polyvinyl alcohol, cadmium chloride, thiourea, sodium selenosulfate and ammonia. Preparation of cadmium sulfoselenide PVA thin films. The chemicals used were PVA, cadmium chloride, thiourea, sodium selenosulfate and ammonia. Here in this figure we can see the setup of the CVD method. Glass slides which are used were of dimension 7.5 cm by 2.6 cm by 0.2 cm respectively. Before the deposition of the film, the glass slides were very carefully washed in nitric acid, acetone and finally with distilled water. In this deposition process, the of cadmium sulfoselenide PVA thin films, cadmium chloride, thiourea and sodium selenosulfate were used as a source of cadmium 2 positive, sulfur 2 negative and selenium 2 negative ions respectively. The sodium selenosulfate was obtained by refluxing selenium powder 2 gram with sodium sulfite 8 gram in 200 ml distilled water for 4 hours at 90 degrees Celsius. The glass substrates were inserted in a beaker. First of all, 20 ml solution of 0.25% PVA solution and dilute solutions of 20 ml 0.25 molar cadmium chloride and 10 ml of 0.25 molar thiourea mixture were taken in a beaker and they were mixed thoroughly. Then 5 ml of sodium selenosulfite was added. Ammonia was used as a pH adjuster and the pH of the solution was maintained at around 10. The reaction mixture was kept in a water bath and the temperature of the water bath was increased to 75 degrees Celsius. After the deposition of the films, the color of the films were found to be reddish orange. After deposition for 1 hour, 2 hours and 3 hours, the deposited films accordingly coded as S1, S2 and S3 were removed, washed with distilled water and dried naturally and kept in a dark desiccator containing silica gel. Here in this figure we can see the images of the 3 deposited CdSSe films by chemical bath deposition method. The XRD analysis of the 3 samples were also carried out. Here in this figure we can see the XRD spectra of all the 3 samples. X-ray diffraction pattern for the CdSSe PVA thin films on glass substrate at bath deposition temperature 75 degrees Celsius after deposition time of 1, 2 and 3 hours respectively were taken. Films possessed hexagonal crystal structure. There were three peaks in the XRD spectra. It was 002, 110 and 200 planes which corresponded to the hexagonal cadmium sulfoselenide. The most prominent peak was 002. Average crystallite size was found using their Serrer equation. The crystallite size was found to increase with the increase in deposition time. Here in this table we have calculated the crystallite sizes of all the samples S1, S2 and S3. For S1 the crystallite size was 0.72 nanometer, for S2 it is 0.86 nanometer and for S3 it is 0.87 nanometer. Now the optical studies of all the thin films. UV spectroscopy was carried out using UV spectrophotometer 2600. The absorption spectra were obtained for all the samples S1, S2 and S3. The optical band gap was also calculated using the dot plot. Optical band gap was found to be in the range of 1.96 electron volt to 1.89 electron volt. The optical band gap of the samples were found to decrease with the increase in deposition time of the samples. The Arbeck energy were also calculated for all the samples and it was found to increase with the increase in deposition time. We can see from figure 4 the plot of absorbance versus wavelength. For the sample S3 we can see we have maximum absorbance and for the sample S1 we have minimum absorbance. From the figure 5 we can see all the top plots of the samples. For the sample S1, from the top plot we have calculated the band gap to be around 1.96 electron volt. For S2 the band gap is 1.93 electron volt and for S3 the band gap is found to be around 1.89 electron volt respectively. From the figure 6 we can see the plot of absorption coefficient versus wavelength. From the absorption coefficient versus wavelength plot we can see for the sample S3 we have maximum absorption coefficient and for sample S1 we have minimum absorption coefficient. In this table we have calculated the band gap and the Arbeck energy for all the samples S1, S2 and S3. And the band gap we have calculated and it was found to decrease with the increase in the deposition time for the samples and for, the Arbeck energy was found to increase with the increase in deposition time. The relationship for optical band gap calculation was alpha h nu equal to a h nu minus eg whole to the power half, and the relationship for the absorption coefficient and photon energy was alpha equal to alpha naught exponential h nu over u, where eu is the Arbeck energy. The deposited thin films were characterized by using FTIR spectroscopy. Here in this figure we can see the FTIR spectra of all the three samples. The FTIR spectra was used to determine the formation of cadmium sulfoselenide and PVA thin films. The associated functional groups contained in the deposited thin films are indicated in this figure. The peak at 3420 cm inverse is due to the wedge stretching vibrations of water and PVA molecules. The peak at 2150 cm inverse is due to the NN stretching mood of diazomethane molecules. The peak at 1625 cm inverse is due to the C11C stretching vibrations. The peak at 1033 cm inverse is due to the C single bond O stretching vibrations. The peak at 722 cm inverse is due to the cadmium selenide stretching vibrations. And finally, the peak at 654 centimeter inverse is due to the CdS stretching vibrations. Due to the presence of CdSe stretching vibrations and CdS stretching vibrations, we can confirm the presence of our compound CdSSe in the thin films. The photoluminescence properties of all the thin films were also studied. Here in this figure 8 we can see the PL spectra of all the three samples. PL spectra of the CdSSe thin films were indicated in this particular figure. The excitation wavelength of the samples were fixed at 500 nanometer, and after that the emission wavelength of all the samples were observed at around 750 nanometer. The intensity of the peak at 750 nanometer was found to increase with the increase in deposition time of the samples. And finally, the conclusion. An increase in absorbance and decrease in bandgap energy was found with the increase in deposition time for all the samples S1, S2 and S3. Arc energy was also calculated and it was found to increase with the increase in deposition time. From the XRD analysis, the crystallite size was found to increase with the increase in deposition time. The peak intensity of XRD spectra corresponding to the 002 plane was also found to increase. The presence of the compound polyvinyl alcohol, cadmium sulfide, and cadmium selenide in the deposited thin films were confirmed from the existing functional groups as obtained from the FTIR spectra. From the PL spectra, we got that the intensity of the emission peak at 750 nanometer was found to increase with the increase of deposition time for all the samples. The incorporation of PVA into the CdSSe thin films gave rise to uniform films with good adherence and durability. That's all for my presentation. Thank you, sir. Thank you, everyone. Thank you to all the organizers. Thank you so much.